Welcome to the April 2023 CIECA webinar. I'm Paul Berry, Executive Director for CIECA. The Collision Industry Electronic Commerce Association, or CIECA, develops and promotes electronic communication standards that allow the collision industry to be more efficient. We also provide webinars like this one to help educate both members and non-members on trends that impact systems, processes, and the exchange of data across the industry. Today's presenter is Darrel Miller, API architect with Microsoft. He's responsible for steering Microsoft Graph, the API surface area for all Microsoft M365 SaaS products. His presentation today is OpenAPI, Development Best Practices and Lessons Learned. Following Darrel's presentation, Paulette Reed, Project Manager for CIECA, will provide a brief update on our 2023 R1 release, which launched this week. As we start the webinar, I want to remind you that there is no verbal communication between the participants and the presenter. If you have questions during the webinar, please type them in the question panel on the webinar screen. We'll answer as many questions as possible at the end of the presentation. And now, I'll turn the program over to Darrel.
Thank you for having me. As stated, I am a Microsoft Graph API architect. I also spend quite a bit of time working with OpenAPI as part of the OpenAPI initiative, and just because I love API so much, I spend more time with the IETF working on the HTTP API working group. Today I want to talk through a variety of topics around OpenAPI and some of the things that we've learned in writing the spec and listening to people working with it, and also my own experiences working at Microsoft with our very large API surface area and the OpenAPI usage that we have there, and the tooling that we're also building there around OpenAPI. So let's first just sort of give a lay of the land. Where are we in OpenAPI world? OpenAPI 3.1 was released in about 2017. It is by far the most widely supported version of OpenAPI. It was quite a major update from the V2 that was released back in, I believe, 2015, I think. And most tooling you find out there supports OpenAPI, and most API descriptions you'll find there support version 3.0. About 2 years ago, we released OpenAPI 3.1. It was quite an interesting debate. We ironically had a debate over whether to call it 3.1 or 4, because while it only has a small number of changes in it, one of those changes is actually quite big. The webhooks capability was added in. It added the ability to be able to provide notifications to people or advertise the shape of notifications that your API might provide without needing to have a subscription endpoint. In version 3, you can say, hey, I can subscribe to this API and this is the callback that I'm going to get. But we recognize there are some APIs out there that have webhook type capabilities with an out-of-band registration process. So it's a minor thing. We removed the requirement that you have to provide a path or a paths node in the OpenAPI description, because we saw that people were using OpenAPI documents not as descriptions of APIs themselves, but as containers for reusable components. And they ended up with a paths notion that was an empty one. So minor little change. But the big change was our change in the way we worked with JSON schema. Since the very beginning of OpenAPI, we have supported JSON schema, what was referred to as draft 4, which is now a very old version of JSON schema. And we had a lot of constraints in the way you could use JSON schema within OpenAPI 3. There were some things you weren't allowed to do, and there were some things that we added on top that added some new features like discriminators for modeling polymorphic behavior. And that caused problems with people who were trying to use those JSON schema with JSON schema tooling, because they'd look at the JSON schema and go, oh, that's not a valid JSON schema according to my JSON schema tooling. And so in 3.1, we made a clean break between what is OpenAPI and what is JSON schema, and we officially use any JSON schema that is version 2012, 2020-12 or higher. And so as new features get added to JSON schema, they will automatically be supported. Now, that's more work to get implemented in a lot of the tooling out there. So it's taking a little while to see adoption across all the ecosystem of tooling. And it's getting there. We're starting to see companies adopting 3.1, but it's a slow process. Now, I'll talk a little bit more about this in the future, but we are currently talking about what will be in OpenAPI 4, which currently we are codenaming Moonwalk because it is going to be a fairly significant feat if we are able to achieve it. So as I say, I'll talk more about that as we move on. It was suggested that versioning might be an interesting topic to this audience, and I don't think I've been to an API conference in the last 10 years where it hasn't at least come up at once in the topic around working with APIs, because you ship APIs and then requirements change. New people, if the API works, people want to add new capabilities. They want to do new things with it. And, you know, we're human, we make mistakes. Before I talk more about API versioning, let's just get one thing clear about OpenAPI version. So in an OpenAPI document, it has a little info block where you put the title and it has a version. That version is not the version of your API. It is the version of your OpenAPI description. So as you change the OpenAPI description, as you add more features to it, you expand the description, you'll get more accurate with the description, then you can update that version. And it's not a bad idea to use something like semantic versioning to communicate with the consumer as to whether you just made a patch change or a feature addition, or whether it is actually a breaking change. But when it comes to API versioning, there's lots of opinions out there. Many people will put a v2 or v1 at the beginning of the URL. Many teams put a version as a query parameter. If you look at the Microsoft ecosystem, all of the Azure APIs, they put a version with a date number at the end of their API. And that is how they control and signal to their customers that there has been a change to their API. There's the ability to put things in a version header. There's no right or wrong solution if you feel that you absolutely need to have a version identifier in your API. I will say that with the Microsoft Graph API, we came to the conclusion about 3.5 years ago that although we started with our API being v1, we are just never going to have a v2 API. The Microsoft Graph API is a facade over many, many teams behind who are exposing different kinds of functionality, and the ability for us to coordinate all of those teams to bring a v2 set of functionality with a set of breaking changes all at the same time just had so many potential downsides. Aligning them on time was difficult. The change for customers would be extremely difficult. And so we moved to a different model, an evergreen model, which is a process of deprecating things that we don't want people to use anymore and replacing it with a new thing that's better. And that can be done at any level in the API structure. It can be done at an individual property level, it can be done at a type level, it can be done at a URI, at a path, at a resource. And so what we ask teams to do now is when they come to us and say, hey, we want to change this particular endpoint, we ask them to say, okay, well, just introduce a new one, mark the old one as deprecated, tell your customers they have 3 years to be able to move off that capability and move on. And that gives customers the time for them to adopt those new capabilities within that time frame. If a team turns around and says, hey, it's 2 years, nobody's using the old thing anymore, we say, okay, fine, you can remove it if they can demonstrate no usage. And so that is a mechanism that we found works for us. We don't have to debate where the version number goes because we don't use versioning. There's one other type of versioning, which is the content versioning. And that is an interesting one where you have a possibility where you're using clients and server softwares that are in different versions, and you might have an opportunity where there's a new version of a client software talking to an old version of a server software. And in that point, it becomes important for the client to be able to communicate what version of the data that it is passing, and for the server to be able to say, hey, I only understand these older versions of the data, and negotiation becomes important at that point. But generally, if you are building an API and you own the data behind that API, there's always the latest version. You don't really need to do content versioning either. I realize that's a kind of fast gloss over a fairly deep topic, but it gives you a data point to see what some people are doing in the business. Security is another major topic. It's one of the hardest things when developers come to APIs to be able to overcome that security. And the easiest way for them to be able to do it is just with an API key. You go to a portal, you provision an API key, you put it preferably in a header, not in a query string parameter, because those leak really easily. And you provide that as a way of authorizing a client to be able to call that API. But it's not very secure. It's fairly easy for those keys to get stolen and to be reused. And you have to start doing things like having to have multiple keys and be able to cycle them, and it becomes challenging to have a secure environment with just using an API key. OAuth 2 is by far the most common security mechanism in practice, where APIs need a strong security behind the APIs that they submit. And with OAuth 2, you start to get into, you can distinguish between authentication and authorization, where authentication identifies who is the caller of your API, and authorization says whether or not they are actually able to call that API. And it gets even more interesting when you start talking about lots of different applications calling the same API, accessing that same data that might belong to an organization or a user. And you start to get into this conversation around permission versus consent. And permission is about whether the user who is using the application is allowed to see that data or not. But there's another factor there, which is consent. Did the user say that the application that they're using is allowed to access the data, their data, in order to be able to do the thing that they want to do? And this becomes really important with, as I say, this proliferation of client applications that can do things, and the challenges around phishing that exist today, where it becomes really easy for somebody to be able to be tricked into running some code that then could go and use that user's identity and access data on their behalf when they don't know that that application or that code that's running is getting access. And so you may have noticed, like on a mobile app, where you go and try and use a mobile app, and it will pop up a dialog that says, do you give this application permission to go access this data? And that's the notion of consent. And when you're working with OAuth 2 and you have tokens, there are claims within those tokens that you can use to be able to identify, yes, this application has been consented in order to be able to get access to this data. And then further down the road, you make sure that that user actually can access the data too. And so those two things together become critical. You also run into different scenarios where users are trying to access data, and therefore you know who the user is, and you're able to make sure they're accessing the data. They've got an application that they've consented to do it. That's all well and good. It's the kind of the delegated scenario, as we call it at Microsoft. But sometimes you want processes to run not with a user sitting in front of the application. You want them to be able to run at night, in batch, unattended. And that's where you need this notion of application tokens, where you have the token actually has its, or the application has its own identity, and it has its own secret to make sure that it is truly that application that is making those calls. And in those cases, the application itself is the security principal that is allowed to access the API. And consent becomes a very different thing at that point because there's no user involved in that process. It's worth understanding these distinctions when you get into the business of building SaaS-based APIs. And OpenAPI does have the primitives necessary to describe a lot of these so that you can identify that certain operations are able to access, can only be accessed if the certain roles or certain scopes are available within the token. And so you can describe a lot of these things. You can describe OAuth 2 endpoints and the particular flows that are supported in OpenAPI. Another interesting thing that challenges a lot of people when working with OpenAPI is the notion of, do I put this all in one file, or do I divide it up and put it into a bunch of different files? It's one of those classic, it depends. There are ways that you can split it up, and it certainly is good for organizing your stuff, and especially if you have a large API. The Microsoft Graph API is about, the beta API is about a 60 megabyte YAML file, which is not a friendly thing to have to go and hand edit. So sometimes there's a lot of valid reasons why you want to separate things out. And you can do this with the $ref keyword. The $ref keyword, most of the time you will see it, it's because it's being used for component reuse within a file, and it references other elements within that file. I want to reuse this concept in multiple places. And that's where you see most of the $ref, where it just starts with the hash symbol and it points to an element within the document. But there's also the ability to use $ref to refer to other documents. And you can refer to other OpenAPI documents and then point to those components within those OpenAPI documents. And that is one of the more common ways you see $ref. Those documents that you're pointing to don't necessarily have to be OpenAPI documents. They could be what I refer to as fragment documents. They're a valid JSON or a YAML file, but if you try to run those through an OpenAPI parser, it wouldn't actually work. But you can point to elements within that. So you could have just a JSON schema file. Now that OpenAPI 3.1 is compatible with just standard JSON schema, you can point into a JSON schema file and point at a particular schema. And this is, again, a fairly common practice. However, what you will see is tooling support for these different kinds of fragments diminish as you kind of go from the top to the bottom of this list. Most tooling will support local references. Some tooling will support references to other OpenAPI documents. Even less tooling will support actually pointing to fragments. So for the largest compatibility, what a lot of people do is they'll run OpenAPI files through some kind of preprocessor that can do all of the fragment resolution. So you take your set of OpenAPI files, you run it through a preprocessor that generates a single OpenAPI file, and then you feed that into your tooling. There's one other type of ref that you'll find in OpenAPI, which is a property on path item that allows you to reuse path items. It's kind of weird. It got pulled in from OpenAPI 2. We tried to get rid of it, we couldn't. It just doesn't behave the same way. I would stay away from it if you can avoid it. In OpenAPI 3.1, we had to make a distinction between when you're using $refs in schemas and $refs elsewhere. $refs in schemas in OpenAPI 3.1, because of the JSON schema rules, you can have a $ref and you can put all kinds of properties by the side of that $ref. And you're not allowed to do that in OpenAPI 3.0. We've allowed it a little bit for non-schema objects in OpenAPI 3.1. So you can ref a parameter, but then give it a different description. But there's not very many properties. So there's actually, it's a subtle distinction, but if you read the spec, there's a difference between $refs in schemas and $refs not in schemas in OpenAPI 3.1. And one final point here is the way that you reference those schemas. They might be relative paths on a file system. They may be relative paths from an HTTP API where you go retrieve that thing. And it is good if you can try and structure those refs so that they will work in both places. So if you're working with tooling with a bunch of files on your file system, they work nicely. And then if you deploy them into the cloud, they will still continue to work with the relative referencing. This can be a challenge, and JSON schema has actually introduced a different way of doing this, where it actually uses $IDs. And so you actually assign a URI, not a URL. So not something that can be dereferenced, but just an identifier that looks like a URL as a way of saying, yes, I'm reusing this concept, but it decouples it from a file system and where it physically exists on disk. When we're looking into, can we use this concept more in OpenAPI for Moonwalk in the future? So it's interesting to talk more about why you might want to split your OpenAPI out into a whole bunch of different files. So generally, it's an organization. It's part of the design process. It's, oh, we have the reusable components over here. We have this kind of operation over here. The administrator functions we put over in this other file. Logically, you're trying to group and separate your API in a way that makes it easier to understand the API that you're designing. But as I mentioned, tooling sometimes struggles with those things separated out into different files. And so it kind of comes down to this logical versus physical distinction. When you're designing it, you want it one way, but when you're using it as a description to feed tooling, you kind of want it another way. And the same is a little bit true with YAML versus JSON. Most people, once they've kind of got over some of the initial hurdles with YAML, they find YAML easier to use. It's easier to add comments in. It is just cleaner. There's less visual noise in there, and it's easier to work with when you're editing it in an editor. But there's a lot less tooling that supports the YAML format. JSON's actually a lot faster to parse. If you compact JSON, it takes a lot less bytes than the equivalent YAML file does. And so there's advantages to JSON from a description perspective. We've talked a little bit about reusable components, and OpenAPI has a number of capabilities around reusable components, but there's still a lot of things that are missing. It's hard to say, I want to reuse this set of parameters. And we've been working on, we started a preliminary specification called overlays that would help with this scenario. We talked a lot about a concept called traits that was implemented in RAML, trying to bring that, and we've really struggled to try and balance the need to meet the requirements of somebody who's designing something, and also maintain the simplicity for tooling around the description of an API. And we continue to struggle with that battle, because people want this higher level notion of designing their API, because they want to, when they're building APIs, they want to adopt a set of conventions. OpenAPI allows you to describe a very broad range of different styles of HTTP APIs. It could be a largely resource-based but kind of RPC-like. It could be a kind of command and query syntax type of API. There's a lot of different ways that you can do it, and most companies say, no, this is a set of guidelines that we have. We want you to follow this practice. But then OpenAPI doesn't really provide any rails. You need to use tools like Spectral in order to then go and do the linting to say, oh, they wrote it this way, does that meet our guidelines? And we've struggled with this concept at Microsoft, and we've been working recently on a language called TypeSpec. And TypeSpec is aimed specifically at being an API description language. We are not the first to do this. There are other people who have done similar types of efforts, and it is important to understand this is a design language. It has emitters to be able to emit different kinds of descriptions, and it can emit an OpenAPI description because that's where the interoperability is. And TypeSpec is a TypeScript-based language, so if you're familiar with working with JavaScript and TypeScript, it won't feel too unnatural to you. And because it is a pure language syntax and grammar, it is tooling enabled. So you get all the nice capabilities when working in an editor, being able to say, right click, go to definition, and show me all the usages of this type. And it has advanced abstraction capabilities insofar as it can model inheritance, it can model union types. It has all of those it has the notion of interfaces that are reusable and templating mechanisms. All those things that we've been struggling to try and put into OpenAPI while still trying to keep it simple. We don't really have that constraint in TypeSpec because it's aimed at being a design language that then just compiles and emits to OpenAPI. And one of the magic pieces of magic sauce was what I was trying to say, but that just doesn't seem like the right metaphor. But one of the really cool concepts within it is it has this notion of decorators, where you can say, this is my API description, but I'm going to decorate it with these additional characteristics. And when it's compiling, those decorators are not just static pieces of data. They are themselves little JavaScript functions that can then go and manipulate the model in order to implement the conventions and your API guidelines. So instead of saying, here's a bunch of guidelines that I'm going to write in a document, and now I'm going to have you all go and write OpenAPI, and then after the fact, I will go and use a linter in order to figure out whether or not you did it right or not. This pushes you in the direction of using these decorators in order to be able to embed your conventions directly into the API description. And this is just a little snippet. This is done as an open source project. You can go to the GitHub repo. There's a little playground that you can go play around with to take a look at. But if you see over on the left, we've designed this little service for doing CRUD over widgets, and it has a list and a read and a create and an update with a bunch of everything that starts with an @ is just a decorator. And we have a model there, and in 25 lines, we have the description of how to interact with this widget. If I look at the equivalent OpenAPI YAML, by line 27, we've got to the second operation, and we haven't even described the model. So it's just a lot more compact. It's a lot more manageable. It has the notion of importing from different files, and it has this kind of compiler concept. And so this is just one of the tools that Microsoft have been building in order to enhance their own capabilities in order to better do API design. And this was actually built by the Azure team at Microsoft, and the Azure APIs are adopting this. And we in the Microsoft Graph team are building our own library of decorators that will allow us in Microsoft Graph to create APIs that are the Microsoft Graph convention based. And then we will just emit OpenAPI in order to generate our client SDKs. And I just want to talk about our investment in OpenAPI is huge. We have web services or the web API tooling framework where you can build an API and it will automatically emit OpenAPI using the open source software Swashbuckle. We have our hosted app service where you can host these APIs and then go get those OpenAPI descriptions from that app service. If you want to put an API management instance in front of the APIs that you build, we can use Azure API Management, and it will do throttling and things in front, and you can import OpenAPI descriptions into that in order to set up those proxies. In our citizen developer world, in our Power Platform, we have a scripting language called PowerFX that has a connector that allows you to pull in OpenAPI and then make that API available to scripting languages. And my own team work on a core OpenAPI.NET parser that is compliant with the specification in order to enable getting access to that rich set of data, ensure that the OpenAPI you're working with is valid. And we leverage that library in a lot of other tooling at Microsoft. We used it to go ahead and build our Kiota client generator that I'll talk about a little bit in a minute. We used it to be able to do API transformation. So if you've got some old versions of OpenAPI 2, we can upgrade them to OpenAPI 3. If you've got tooling that only supports OpenAPI 2, you can downgrade it from 3 to 2. And we've got teams building API testing tooling. And Wrestler is another open source product in the OpenAPI space. The big question is, do we support OpenAPI 3.1? Well, not quite yet. We are actively working on it. We will have that support out hopefully by the middle of this year. And the really nice thing is it's going to go into our OpenAPI.NET parsing library, which means that automatically all these other tools, Azure API Management, ASP.NET Web API, they will automatically get the 3.1 support in a consistent way. I mentioned I was going to talk a little bit more about the Kiota client generator, Kiota client code generator. It is a command line tool that will generate from OpenAPI client code to help you call APIs. It takes a bit of a different approach than what a lot of other tools do in this space, in that we are very focused on the API consumer. We're there as a tool to help somebody who wants to call an API, as opposed to somebody who is producing an API who wants to ship an SDK. We kind of have this belief that we need to get people out of the business of having to ship SDKs because everybody tends to do it differently, and then API consumers go, I have to learn yours, I have to learn yours, and when we're talking to different things, they've got to learn a different style of SDK, whereas if a consumer can just use one tool to call any API, then they get a consistent experience everywhere. And I'm just going to take a moment and hope all of my switching between screens works. I'm just going to give you a really, really quick demo of this. And so if you have used VS Code, it has a extensions type capability. And so I have the world's simplest kind of console app here. I happen to be writing this in C# because it's what I'm most comfortable with. And on the sidebar here, there's an extension which we call the Kiota OpenAPI Explorer. I'm just going to make that go away for a second, which gives you this search experience, because what we discovered is consuming APIs is more than just code generating. It's actually also being able to find the APIs I'm looking for. So I want to go call the GitHub API, perhaps. Maybe I want to go and get information about pull requests that are there or issues that are available. So it finds me that OpenAPI description, because it is a discovery problem. And then it shows me the list of APIs as a tree. So I can explore around here, but I happen to know I want to be able to call and access pull requests. And so there's a filter mechanism, so I can say pull. And here we go, we see, okay, there's just one place where there's two places where I can get access to pull requests. I'm interested in this one, and so I'm just gonna select this, because this is what I'm interested in. And I'm gonna go to code generate, and I'm gonna say, I'm gonna call this the GitHub client. And I'm going to put it in the GitHub namespace, and I'm going to put it in a folder called GitHub SDK. And I have a bunch of languages to pick from. We've currently made our C# generation generally available. Go, PHP, Python are close behind, Java, and TypeScript we're working on to try and get those out this year as well. So you pick that, we go when we do generate of a client. And if I now go back to the files, you will see over here, I now have a GitHub SDK. It has all the models that are needed to be able to call this endpoint. And it has what we call request builders to help you make those calls. And we have all the infrastructure in place to make sure we do proper retry handling. We've got pluggable authentication mechanisms. So this is kind of like back in the day when you were using SOAP, you had WSDL in order to go generate a client, well, and XSD to generate models. Well, this does all of that, but based on OpenAPI. And it doesn't just work, like for one, it can work for anything. So if I want to go and search instead for Stripe API, I can find that API description here. And we have a pluggable search mechanism. So other search providers can add things in, and you can actually go into GitHub and tag your repos to say, now make this available in the Kiota search, and it will appear there. So I can go here and say, yeah, I want to do balance, because I want to go get the balance of my Stripe account, and now I do a Stripe. I go through exactly the same process. I'm going to put it in the Stripe namespace and call it the Stripe SDK. And now I have consistent SDKs that behave in a very, very similar way, but I've only generated code for the parts that I care about. When you work with an API the size of Microsoft Graph that has about 22,000 endpoints, nobody calls all of those endpoints, and it becomes a size problem. And so we want to give people the ability to just generate the code for just the parts that they care about. And that is a completely open source project. We are actually working now with Red Hat. Red Hat are building their cloud SDKs using Kiota. We're in conversations with GitHub too to generate SDKs for them. And this is a piece of tooling that we are going to continue using for our own Microsoft Graph customers. So let's get down to more information around the OpenAPI specification itself and the work that's going on. One of the things that a lot of people don't know that we've done outside of the specification but within the OpenAPI initiative is we've created a set of registries. We have the format registry, which I'll talk about a little bit more. You can do extensions in OpenAPI, and we've created a namespace registry so people can say, hey, SAP of like, yeah, we've got a bunch of extensions that are under x-SAP. We want to go and reserve that namespace so other people don't start creating extensions within that same area. And it provides a discoverability perspective. If somebody wants to go and find the namespace, the extensions that other people have created, they can come here. We have a couple of others that don't have a lot of adoption. The draft features registry and alternative schemas, you can discover all of those at the link I put at the bottom of the slide. The format registry is interesting in that when you're working with JSON schema works around JSON, which does not have a rich type system. You basically got object, array, string, Boolean, number. But you know that we need to work with a lot more different data types. And so when you're trying to communicate that in OpenAPI, you need to rely on a format proper keyword in JSON schema. And the values that you put in the format have not really been very well specified in the past. Older OpenAPI specifications define some, JSON schema specifications define some, but there was no one place that you could go and use as a definitive place to go, okay, what's the right keyword to use, or what's the right value to use for the format keyword, and point me to the specifications that will tell me how exactly that value is going to be formatted. And so this is what the formats registry is there to do. You can also find about the entire ecosystem of OpenAPI tooling. There's a new repository at tools.openapis.org that we automatically scrape GitHub, and we have a submission mechanism. So if you have a tool that you're building, and we automatically classify the tools into different categories. So it's a great place to go find tools that are available to do a wide variety of things. There's also a website called OpenAPI.tools that is a community curated listing. And so you'll find it'll take a little longer for items to get on the list, but somebody's actually gone and tried the tool out and made sure that it works for the versions of OpenAPI that it says it does. And so there's a couple of resources there to help you find how rich the tooling ecosystem is. There's also a variety of different places to get documentation around OpenAPI. If you go to the oai.github.io/documentation, which is a little hard to find, and we need to get that up on our front page on the main OpenAPI website. There's a getting started there that walks you through the process of understanding what OpenAPI is all about and how to construct good API descriptions. There's some best practices listed in there also. So it's a great place to point colleagues to who are trying to learn this for the first time. And I have to point you to the amusingly named APIs You Won't Hate website, which has an absolute ton of great content of articles and podcasts around the API space and around OpenAPI too. And there's a couple of books here that also have some great content on OpenAPI. And so I want to just finish up by talking about a little bit about the future. Moonwalk is our next version. You can find we do this all out on our GitHub repo. As I mentioned before, it's quite a big effort in order to change and make more flexible OpenAPI whilst also making it simpler at the same time, which is a fairly conflicting challenge. What we want to be able to do at the moment, when you create a path item, you can create one operation per method. And it is constraining because it means that you can't have query parameters that cause different responses to come back. And so we now in Moonwalk use a notion of using a JSON schema for pattern matching in order to be able to define a set of requests that will potentially return different results based on query parameters, headers, request bodies. This will allow us to accurately describe RPC protocols like JSON RPC that actually uses an identifier in the request body to say what the response is going to look like. We are moving to, or at least we're considering moving to using proper URI templates in order to identify paths so we can support things that we couldn't in the past, like optional path parameters and multi-segment path parameters. We are, this new model reduces nesting. It allows so your API descriptions don't get as deeply nested. It also allows you to define responses not only just at the request level, but also responses at the path level. So no matter what request you call, here are potential failure conditions, or you can even define standardized responses at the API level. You can always override them at a lower level, but this addresses some of that reusability things that we weren't previously supporting. And so I encourage you to go take a look at it. We have a lot of discussions open in the GitHub discussions repo. If you have things that you think we could do more of, there's lots of things happening and discussions happening there that we'd love people's contributions on. We have a number of special interest groups that are doing some other interesting work. One of them is our workflow SIG, and they are defining a format that allows you to describe how to connect a set of OpenAPI operations together in order to achieve some larger goal. And they have a process of being able to describe both the inputs and the outputs of each step in order to feed into the next one. So there's some great work going on there, and there's a link to the current specification. There's also an effort around describing SLAs for APIs. If you want to do consumption-based pricing on that API, we have an effort around standardizing all of these capabilities. So there's all kinds of interesting work that is happening in this space. It is all completely open to anybody who wants to come and contribute. And hopefully we can start to get some of the scenarios that you are using in your industry and help where you see there are shortcomings and get your experience and feed it back into the process so that Moonwalk can be an even better product for your organizations and your companies in the future. And with that, I will open the floor to questions.
Thanks, Darrell. Great information. Really appreciate it. Paulette Reed has been monitoring the webinar. Paulette, do we have any questions for Darrell?
Yes, we have one from Bill Garut is asking that, do we think that we will ramp up YAML in addition to JSON?
I think YAML and JSON will always be peers. We will, as far as I'm concerned, with regards to the API description language, we're always going to support both. There's enough people who want to live in both camps that I see no reason to change.
Thank you, Darrell. And Bill, just to let you know, and Bill says thank you, but our standards for CIECA is both in YAML and JSON. Our second question is from Paul Berry. He was asking if, so that you mentioned there are multiple ways to handle versioning. Would you recommend one of them as a best practice?
Yeah, I recommend don't. But I know it's a religious subject. Versioning is pushing your problems because you need to make changes onto your customer, so your customer has to deal with them. There are, in 90% of cases, there are ways to evolve your own API so that you can incrementally add the new capabilities that you want without breaking existing customers and giving your existing customers a path to that new, better value. We make exceptions for security and privacy at Microsoft. If we run into a security issue or a privacy issue, then yeah, we'll break you. But other than that, no.
Great. Thank you, Darrell. Much appreciated. All right, I'm going to turn the floor over to Paulette Reed now. And Paulette's going to give a quick update on our most current release. So Paulette, take it away.
Okay. So I wanted to start with just giving everybody a little update on the CIECA API project that we're working on, so that to tie into Darrell's presentation. So right now, our CIECA Architecture Committee is working on the API standards that in converting the BMS over to the CAPAS project. So I don't know if you guys are familiar with how we started, but at first we started with, we did a conversion of the BMS over to OpenAPI, and that was huge and wasn't really productive. So then the architecture committee started working on the process of flattening out the BMS aggregates. Our aggregates in the BMS used to, if it was like 10 fields, we would break it down and have a hierarchy. So what we're doing now with the APIs is flattening that and pulling everything out that we needed. And we're also doing a zero-based budgeting. So if it's something that was out there and we don't use it any longer, we are removing that. It easily can be put back in if somebody does say that they're using it, but we know that there are some things that were just out there for backward compatibility that is now being removed. And then of course we'll have our new code list. So the architecture committee, they meet weekly. It's an hour-long meeting and it's at noon Central Standard Time. We would welcome anybody from your technical teams, architecture, to help come in and help us with this development. We're really looking to make this across the industry and want everybody's input. Right now we have like 4 companies that are really working on this initiative, but we would like to see more companies come in to make sure that, again, this is going to be best for everybody in the industry. So if you would like to help with the API standards, you can contact me at paulette@cieka.com, or you can go through the website and contact and request to be part of a meeting that way. So to give an update on our 2023 R1 BMS release that we just had yesterday, the changes to the BMS is we added a consumer privacy indicator that is found under the party aggregate. If the indicator is set to true, personal information is included. If it's set to false, no personal information is included. Personal information means information that is linked or reasonably linked to an identifiable individual consumer, but does not include de-identified, aggregate, or publicly available information. And this is also in our version of CAPAS, our first version of CAPAS that we released. And then our second addition to the BMS was the title category code list edition, which was prior salvage. And it came in with the vehicle has previously had salvage certificate of title issued in Minnesota. So that's a new regulation that Minnesota has put out there, so that we added that code list for that. So to access the 2023 R1, you can go under CIECA.com and you'll have to sign in, of course, to get to that. And then you go to our standards and you'll be able to scroll down and get to the BMS. We have the CIECA BMS releases, and if you click on the read more there, it will take you to the archived and the current folder that will have all the information in the zip file. And then we, of course, have the links to the BMS, the master code list, schemas, and our test instances. And other changes that were made for this release was in CIECA Simplified, where we're working on getting all of the information that is in the Word documents over onto the website. So those test instances have been moved there so that we can have those implementation guides reference those documents instead of having it in a Word document. Okay, that's all I have, Paul.
Great, thanks, Paulette. This presentation has been recorded and will be available later today at CIECA.com. I'd invite you to check CIECA.com for a schedule of future broadcasts and to watch recordings of past webinars. Links are available under the CIECA tab at the top of the page. Please follow CIECA social media platforms to stay up to date on upcoming events and CIECA news. And that concludes today's webinar. Thank you.